Okay, the review quiz for chapter 12 is open until the 10th, which is next class period. Somebody asked for the skills check to be reopened, so I will put it also through tomorrow night. 13, I'm sorry, thank you. Somebody else asked for chapter 12 too, though, so that'll take care of that. So will tomorrow night be enough? Okay. And I'll open the review homework in case you need it. The skills review homework. And then all of chapter 13 is open through the 9th, including the quiz. See, that actually needs to be the 9th. And I'll reopen the homework too in case you need it. Chapter 14 is unassigned. Chapter 15, I'll give you until the 11th to get your skills stuff done. That way it'll be after the test. And then our test over chapter 15 won't be until December 5th, which will be our last test. Okay, and it will be our last test. I will not give a comprehensive final. Okay, our next test, which goes for the 13th, will be on Thursday. You'll have until Friday to get the skills quiz done for chapter 15. Okay, remember chapter 15 is you're going to be given the derivative and have to go back and find the function. It's a little bit different. So we'll spend the rest of the time after Thursday on chapter 15. And then the final exam will not be comprehensive. Normally I give a comprehensive final, but I'm not going to make it comprehensive this time. You'll have a final exam, a last test over just chapter 15.
But is that final going to be still worth 25% of our grade?
No, I think I'm going to count it as just a regular test grade.
So 4 of our tests will be.
Yeah, I'll, since we've had to change things, I'll equalize the percentages out and I'll tell you how everything works out.
So pretty much all of our tests will be worth the same grade, and we'll have our homework quizzes.
Right. And what would have been the comprehensive final, I'll probably put on homework and quizzes instead. Okay? Merry Christmas early.
Now I can breathe.
Okay, everybody let's go. Get a good deep breath.
I'm ready. We're done.
So our last test is December 5th?
Our last test will be whatever day the final exam schedule says it is. I'll have to look.
Oh, okay.
But it'll be the first week of December.
Is it Thursday the 8th?
Seems like that's it.
Yeah.
Because I,
Because
Lisa-
most of our Thursday classes are all on Thursday.
okay.
I think it's fine.
Well, and if it's
1:30 to 3:30.
if it's too intensive for anybody that they have like 2 tests in one afternoon that's like back to back, you can come to any of my final exams that fit your schedule. And I will give you the list of all my final exams.
What's the question?
Question was, when is the final exam? And without looking at the final exam schedule, I don't actually
I
know.
believe it's the last week of school and it's on Thursday.
Yeah, I think it's on Thursday, but I just,
Yeah, takes time.
So it would be on the 8th from 1:30 to 3:30, okay? And don't go around telling all your friends that calculus doesn't have comprehensive final. Theirs may very well have one, it's just yours doesn't,
I will not tell her so.
okay?
So she could change her mind.
Yeah, there's plenty of time to change my mind, I just usually don't. Okay.
But you don't have to.
No, I don't have to. Okay, we're gonna solve this problem. This problem is worth 15 points total on your last exam, so you need to look back at that exam, and if you missed it, you need to follow along with me on how to do it. Okay? This is number 12 on the test. Part 1, Part A, are 2 points each. This is the function that we're given. It's a profit function. It's the profit from selling X units of a product, and it's X squared over 2X plus 1, so it's a quotient problem. The first thing they give us is to find and interpret the marginal profit. The word marginal always indicates derivative. Okay, it will always indicate a derivative. So what they're telling us to find is P prime of X. And since P of X is a quotient, I'll model the way that I want you to do your practice. A quotient has a numerator and it has a denominator. So what I want us to find are the derivatives first of the numerator and the denominator. So the derivative of the numerator, which is what I'm going to call n prime, is going to be 2x. And the derivative of the denominator, which is 2x plus 1, I'm going to call d prime. And the derivative of 2x is just 2, plus the derivative of 1 is 0, so it's just 2. So the derivative of our profit function, P prime, is going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. Yes.
Our exam will allow us to have our formulas as well.
Yes, you'll have a formula sheet.
We use this as like the,
Yeah, I will give you a formula sheet for derivatives, and there will also be a formula sheet for integrals, which is what chapter 15 is about. Okay, so remember your denominator shows up in 2 different places, and its derivative shows up once, whereas your numerator shows up once and its derivative shows up once. So let's take the derivative. P prime of X is the derivative, the denominator, 2x plus 1, times derivative of the numerator, minus the numerator, x squared, times the derivative of the denominator, which is 2. And that's all divided by the denominator, and it's squared. And that really is as far as you have to go as far as simplifying. If you want to simplify it further, that's fine, but you don't have to. And then it says, find and interpret the marginal profit when the following numbers of units are sold. So they're telling you to find P prime of 4. And you can do that just as well with it this way as you could if you actually tried to simplify it. It just takes a little more arithmetic. So what you're going to do is you're going to plug 4 in for x. So 2 times 4 plus 1 times 2 times 4 minus 4 squared times 2 over 2 times 4 plus 1 squared. So basically every place that there was an x, I put in 4. That's the only thing that we did. And now we're going to do some arithmetic. 2 times 4 is 8, and 8 plus 1 is 9. 2 times 4 is 8, so that's 9 times 8. Minus 4 squared is 16 times 2. 2 times 4 is 8 plus 1 is 9 squared. Times 8 is 72, minus 16 times 2 is 32, over 9 squared is 81. 72 minus 32 is 40 over 81, and you can get a decimal answer for that. Since the profit is in dollars, think about that. If we're talking about money, then 2 decimal places. So this is going to be $49.38. And the interpretation of that marginal profit at 4 units produced is $49.38 per unit. And that's when 4 units are produced and sold. Okay. Now, the faster way to do this, even though we could go back and plug in the other numbers, because part B says 12 units and part C says 20 units. The other way we can do this is we can also do the numerical derivative using your calculator. So you go to your math button, in deriv, you enter in your profit function because it's going to take the derivative for you numerically. So your profit function is x squared divided by the sum of 2x plus 1. You take it with respect to x, and for those of you that have the 84, the x had to come first, then the function. And then the value of x that we want to evaluate it at is 4. We'll just check the answer we've got. And it says it's $49.38. So if we did the exact same thing and plugged in 12 instead of 4, then the marginal profit for 12 units is $49.92 per unit. So profit is increasing by $49.92 per unit when you make 12 units. And then same thing for 20. It's $49.97 per unit. When you make 20 units. Okay? Learn to use your tools. You don't always have to slog through all the algebra and the math yourself. You can use your tools when you're doing things numerically. And the question says, what's happening to the marginal profit as the number sold increases? As the number sold increases, the marginal profit, you notice here, is going up. But if you look, and we'll investigate this numerically, what if they sold 100 units? $49.98 or 99. 500 units. $49, $99, $99, $99 on. $1,000 units. Million units. 0.5. Okay? And it's not going to go up anymore after that. It's going to level off. Well, actually it dropped off again. Because I guess at some point you're finally going to produce so many that you're not going to sell any of them. Okay? So your marginal profit is going to be increasing, but so realistically, it's never more than $50 per unit. Not going to go any higher than that. Okay? Now, if you were to actually graph it, what it eventually looks like is that the profit's going to go up, it's going to level off slowly, and then at some point it's going to take a nosedive and drop off again because you've exceeded your what's called the carrying capacity. Okay? Well, the last one is one that I think tripped a lot of people up. Because the last one says, find and interpret the marginal profit when 4 units are sold. And it says marginal average profit. Find and interpret the marginal average profit. Average profit is the profit per unit, and the marginal average profit is the rate of change in the average profit per unit. So we need first to find the average profit. And that's always going to be the profit function divided by X, or some people chose to look at it that it was the profit function times 1 over X, and either one is fine. It's just here you're going to have to use a quotient rule, and here you'll be using a product rule. And you'll have to change that to X to the -1. But it looks like this. And the easiest way to think about that one is that it's x squared over 2x plus 1 divided by x. Because if it's divided by x, you can find the average profit this way. So you multiply it by 1 over x, which is what this one does, straight out. And then x squared times 1 is still x squared. And x times 2x plus 1 is 2x squared plus x. So there's your average profit function, and you need to find the marginal average profit. So you're going to take the derivative, and again, its denominator times the derivative of the numerator, which is 2x, minus the numerator times the derivative of the denominator, which would be 4x plus 1, all divided by the denominator, and it's squared. And here again, you can just plug in 4 at that point. So you could find it numerically by saying this is 2 times 4 squared is 16 plus 4. 2 times 4 is 8 minus 4 squared is 16. 4 times 4 is 16 plus 1 over 2 times 4 squared is 2 times 16 plus 4, and we're going to square that. So 2 times 16 is 32. 16 plus 1 is 7. 32 plus 4 is 36. Times 8 minus 16 times 7. Over 32 plus 4 is 36. And we're going to square that. So let's do a little arithmetic. Thank you.
Isn't it second?
Did I miss something?
When you start at adding, it's 17.
Oh, 17, thank you. That makes a huge difference. Thank you, Tony. So we've got 36 times 8 minus 16 times 17 is 16 over 36 squared. And it comes out to be 0.0123. And since that's in dollars and cents, we're going to have to round that to 0.012. So 1.2 cents per unit. Okay? And before we actually state that as an answer, we're going to do the same thing we did up here. We're going to go to math and derive. We're going to enter the profit function, the average profit function. The average profit function turned out to be x squared over 2x squared plus x. With respect to x, at the value x equals 4. Get the same answer. So here's what that means.
So I have a question, the other one's when we use interest, and we come out to 24,992, move the decimal place to make it a whole dollar, not at $49.92.
Yes.
But you're not moving the decimal place on this one?
No. I think I messed up before. I think I interpreted it wrong. Let me look back. No, we didn't.
When we entered it in, it came out to 24,992 for.
No, I misinterpreted what it was, so thank you, Shannon. Wait, let me check my answer key because,
Okay, so one of them's wrong, because we're
Yeah.
moving the decimal point on one and not the other.
yeah, and we should be moving the decimal point on both. So let me find my answer key because I ran across that before. No, that's 49 cents. So let's go back and fix that. That's 0.4938.
No, it's in hundreds of dollars. So it's.
Oh, no, it is in hundreds of dollars. That's why. That's why. So we need to move the decimal on this one too. Sorry.
Right, so I knew one of them was wrong.
Yeah.
Okay, so it is the one that you're saying is,
Yes.
0.01,
So we're going to take that 0.0123 and we're going to multiply it by 100.
which would be $1. Okay.
So $1.23. So the average profit is increasing by $1.23 per unit to sell the 5th unit. So you've sold 4 units, so your profit is going to increase by $1.23 on the 5th unit. Okay? It's increasing by that much on the 5th unit. And that would be a different amount if we did the marginal profit at the 10th unit or the 12th unit. This amount is going to change. And in fact, what's going to happen is it's going to become less and less. Okay? The key thing to watch out for is the language. Watch the words and always look for the word average, because average can trip you up if you don't take the average before you take your derivative. Now we have one left. You're given a table of information. The only thing you have to be extremely cautious about is you have to read what it tells you to do about aligning the data. This is referred to as aligning the data. So we're going to use the regression on the calculator. Find a cubic, that means a function that has x cubed in it, and a quartic. And this is what caused some people some problems. Quartic is 4th power. Quadratic is not quartic. Quadratic is the 2nd power. We want 4th power. The second thing to be cautious of is this says let t equal 0 correspond to 1900. So your x values here are 0, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. You go to your calculator. There's no way to do this one by hand. Don't even try. You go to your calculator, and in list 1, you enter your X values. 0, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. And I had already entered these in at the beginning of class last time, I think. So I'll just check them. Your Y values is the percentage of men 65 or older that are in the workforce. In 1900, that was 63.1%. In 1920, it dropped to 55.6%. In 1930, it was 54%. 1940, it was 41.8%. And then in 1950, it started coming back up to 45.8%, but it dropped back down again in 1960, 33.1%. And then 26.8%, 19%, 16.3%, 17%, and 20.5%. Okay? But basically what you're measuring here is the percentage of men that were in the workforce that were eligible for retirement. Essentially, you'd expect them to be retired. And this is actually, if you look at this and think about the whys of it, it has to do with number 1, the Depression, number 2, a war, and then number 3, some economically better years, and then an economically challenging couple of decades here during the 70s and 80s when people worked longer, but also healthcare got better, so there were a lot more people that were older that continued to work. And then it dropped down again until about 2010. It increased again because, again, there's a downturn in the economy. So what they want us to do is find a regression feature that lets us model this over time. So what we do is we go to Statistics, over to Calculate, and Cubic Regression is number 6, Cubic Reg. Your X values are in list 1. Your Y values are in list 2. And if you think you might want to investigate what the graph looks like, you go ahead and hit your vars key and choose Y vars and function and Y1, because that'll actually let you look at the graph if you want to look and see what the graph's doing. But you need to be careful when you write that equation, because I want you to look at these coefficients. That first coefficient is not 1.0348493. It's times 10 to the negative 4 power. So the cubic equation is actually going to be 0.0001348 or 10348. X to the third minus, because B is negative, 0.0154460 044 X squared plus 0.06 152 25 X plus 62.096. Now, if you didn't write out all the decimals, that was okay. It would have been perfectly fine if you had rounded these to about 5 decimal places. So 1, 2, 3, 4, 5. That would have been fine. 1, 2, 3, 4, 5, which makes that 5. Scratch the rest of those. And then 1, 2, 3, 4, 5. And since this is actually the percentage in year 0, predicted percentage, because it's not actually the percentage, but it's the predicted percentage, it would have been okay to round that to even 1 decimal place and call that 62.1. But you did have to realize this first one wasn't what it appeared to be. You had to be careful about that. And if you investigate what's going on, let's go set the window from 0 to, let's say, 125 years, which takes us to 2025. And I put the equation in there, but I need to get rid of that. So we'll turn the stat plot on and tell it we want the scatter plot. This part wasn't necessarily the problem. This is just so that you'll kind of understand what's going on. And then do zoom 9. That's what it looks like. Okay? And if you want to do the same thing with the quartic, just go ahead and do stat, calc, and be sure you choose number 7, quartic. And again, it's list 1, list 2, and then if you want to store your equation, store it in Y1. So for your quartic equation, again, look carefully. The coefficient of the first term has 5 zeros in front of that 1. The second one has 3 zeros. And I am rounding these as I go. Plus 63.1, which actually does align it with the predicted, with the actual value. The prediction and the actual are the same in this case. So there's your quartic regression. And if I graph it, it looks just a little bit different. But it's still a relatively good fit to the data. And then it says, using each of your answers to Part A, find the rate that the percentage of men age 65 or older in the workforce was increasing in 2005. So what you want is the derivative. And you could take this on your own numerically, but it would have been far easier. And I'm going to go over here and actually have it put in the quadratic at Y2. So I'm going to redo that one so we can do it numerically. Because I don't want to type all those numbers, and I bet you don't either. So let's go stat. Well, let's just do second enter. And I'll put the cubic in Y2. So the quartic one is in Y1. My cubic one is stored in Y2. And again, I can come to the front page, hit my math button, and do numerical derivatives, so I don't have to take those derivatives. And first one I'll do is Y1. So that's the quartic. And in 2005, that would be 105. So in 2005, the rate of change for the percent of men age 65 or older in the workforce was about 51.3% per year. Whereas if you look at the cubic regression, it's only about 24.1%. So they predict differently for the year 2005. That's because of the fit of the data. So on that part B there, the best answer is to use your calculator, use your technology. Don't try to do that by hand. Okay? Anybody have any questions on the test? Yes?
Why is it in percentage? Why is it 51.3%?
It's percent per year.
Right, but why is it not changing like 0.51%? That makes sense. Because it's not changing 51% any year. That's a lot of percent.
That's a good question. Because the actual, let me go back up to the top of it and read it again, because I may be misinterpreting, so let me look back. Because I look more at the numbers here than I did the actual units. So let's see. So this is the percentage of men, and this is the change in the years. Yeah, I think you're right. I think it would be percent per year, and that you would leave the decimal. It would be 0.513% per year and 0.241% per year would be the way that you'd interpret that. Okay? Okay, and I don't think enough people got that last answer right that I paid any attention to the units. I looked for the numbers. Okay? Be sure you know how to do a problem like this. You probably will see something similar to that on the test. Is that enough warning? You'll probably see another one like that. Okay, that takes care of the test. I have given you your practices. The one for the logarithmic functions, I gave you the equations at the top of the page. The one for the exponential, I gave you the formulas at the top of the page. The one for the chain rule, I gave you the explanation at the top of the page as well as the formula. Because in these, I want you to identify U and identify V, where U is the outside function and V is the inside function. So just in order to help you out, I'm going to help you with the first one. Problem number 1. U is equal to the parentheses to the 4th power. That's it. There is something in there. Yeah, I know there is, okay? But it's the parentheses to the 4th power. V is what's in there. Okay? So V goes in here. You don't need to worry about writing it out twice. Just put it in there as V. And then U prime is 4 times the parentheses to the 3rd power. And V's what's inside the parentheses. And then V prime is this. It's the derivative. So 4 times 8 is 32, x to the 3rd, minus 3 times 5 is 15, x squared, plus 1, the derivative of 1 is,
It's not quite x cubed, it's
Is it-
x squared.
oh, thank you, squared. So then that's just 5x. And then the derivative of 1 is 0.
Negative 10x.
Hmm?
You multiply 5 by
Thank you. I'm not being a lot of help, maybe I should leave it to you. Okay? But identify u, the outside function, identify the derivative of u, the outside function, and if it's got a parentheses or a square root sign or an ln in front of it or whatever, you don't bother rewriting what's inside, just call it v. Because then you're going to need to take the derivative of v. So then when you actually take the full derivative, the derivative rule says to take u prime times v prime, because that's really what you're doing. So your derivative, which is y prime, is this derivative times this derivative. And then still what goes inside the parentheses is 8x to the fourth minus 5x squared plus 1. And you don't have to go any further than that. You can stop right there. Derivative of the outside times derivative of the inside. And the inside is what gave you that. And the outside may be parentheses with a power. It might be a square root sign. It might be an ln. And the inside function may be complicated. It may be a product rule, which means you'll have to use the product rule to take its derivative. So it may be a product that's in there, or a quotient that's in there. So the outside function is either an exponent, a radical, or a natural log. Something that's operating on the function, not just a constant coefficient in front of it. Okay? I will post the answers to these. Every single one of them. I'll post them probably later on this evening. So you'll be able to check them. If you want to check them before then, I'll tell you where I got the problems. The problems are from the end of the section for the section on the product rule. I took the first 10 problems. On the quotient rule, I took the first 10 problems. On the chain rule, I took the first 10 problems. And then because I knew that y'all were having quite a bit of trouble with the log functions, I gave you more practice with those. So I did 20 functions. You'll recognize the problems, you just don't look in the book. It's in the e-text. So if you want the answers before I get them posted, just look at the answers in the back of the book. They're actually in your e-text. And the same thing for those. Yes. The test will be similar to the setup for chapter 12.
You're just pretty much gonna change the numbers around the same.
Same kind of problems, I'm just going to change the numbers around. Okay? Now, chapter 13. Let's look at a review of chapter 13 and see what I might be likely to ask you. And here again, I'm going to go to the book because the book's a good resource. You've got the complete answers to those in the back of the book. So let's look at chapter 13. And when I post the answers to these reviews, I will also post the answers to the review for chapter 13. I'll just send out the whole thing to you. Okay, I would probably ask you to do one like, let's see, one of these.
So,
748. And what you're doing to find that is similar to what you're actually going to do to find these as well. What you want to do on those is you want to actually, and I'll pick one of them and work it. I'll find a piece of paper. Here we go. Let's just look at number 18. I'm actually going to do an example with number 18 of the second one too. So here's the problem. Find open intervals where f of x is increasing, decreasing, and it could also be zero and constant on intervals. Now actually this function might be zero, but truthfully on this particular problem you're not ever going to have it be constant. Okay, it's not ever going to be horizontal. Not for an interval. Might be for a point, but not an interval. The way that you do that is you first take the derivative of f of x. So 2 times negative 2 is negative 4x. 1 times 7 is 7. And derivative of 14 is 0. So here's the derivative. You take the derivative. And you set it equal to 0. So x is 7 over 4. Which is 1.75. So there's your first step. Second step is you draw a number line. You locate that 0 point on it. You locate where 0 is and where another number bigger than 1.7, like, for example, I'm lazy, 2. Okay? This line goes on to infinity in both directions. F of x is equal to 0 at this point. Okay? If I plug in x equals 0 into the original function, 0 plus 0 plus 14 is 14. It's positive. which means for every number that's less than negative 1.75, the derivative is positive. That means your f of x is increasing. It has a positive slope, okay? If I plug in 2 squared is 4 times negative 2 is negative 8, plus negative 14 is negative 8, plus 14 is should be negative. Probably better do that one on the calculator. My head's not working that good. Negative 2 times 2 squared plus 7 times 2 plus 14 is 20. So it's again positive. So, again, slope is increasing, okay? So the intervals on which f of x is increasing or decreasing
Use the original function or the derivative?
the original function. And I'm not supposed to be, I'm supposed to be using the derivative. That's where my brain leaked. Sorry, guys. I need some more coffee. McDonald's coffee don't cut it for me. I need Starbucks. Let's try again. We're not supposed to be using the original function. We're supposed to be using the derivative. So the f prime of x equals 0 at 1.75, which only leaves us with 2 intervals. An interval where 1.75 goes up to infinity, and an interval where it goes down to negative infinity. So we're going to pick 0 on this side and 2 on this side. We're going to plug it into the function. I'm sorry, not the derivative, into the not into the function, into the derivative. Because we're talking about the derivative, the value of the derivative. So if I plug in 0 into negative 4x plus 7, what do I get? 7, which is positive. Which means the derivative is positive, which means the slope is also positive. And if the slope is positive, that means it's going up. Okay? Plug in 2. Negative 4 times 2 is negative 8. Negative 8 plus 7 is negative 1. It's negative. And if you're not sure, pick another point. Pick 5. You just want to be certain. Negative 4 times 5 is negative 20, and negative 20 plus 7 is still negative. That tells you that the derivative at that point is less than 0, it's negative, which means the slope of the function is less than 0, which means the function is decreasing. So the answer is f of x is increasing for all x from negative infinity to positive 1.75. F of x is decreasing for all x from 1.75 to positive infinity. The next one would say find the locations of maxima and minima. What happens when a function goes from being increasing to being decreasing? What happened at 1.75 on the function? It reached a max. And that's all you need to say.
And that's what it's referring to, the maximum.
Maximum and minima, or the maximum value, the vertex, turning point. There's a lot of different words for it. Okay? The second derivative is how you find inflection points. This function has no inflection point because it's a quadratic function. It goes up, reaches a maximum, goes down. But a cubic function doesn't do that. It goes up, wiggles, goes up some more. And the wiggle is not a maximum point or a minimum point, it's an inflection point. So down here, these are asking really the similar things. Most of the ones that I'm likely to ask you are going to be actually coming from this. So those right there are the problems you want to really look at on section 13. You want to look at 39 through 50. I'll probably ask you one of those problems, exact problems. I probably won't do any of these because it's just more complicated derivatives that you'd have to take.
What page are you on?
That was on 748. And looking at the derivative, the problems at the end of 13, I will not take an application from the end of chapter 13. I don't like any of the applications they have. So chapter 13 will be like those problems I just showed you. Chapter 13 will be problems like 39 through 50. Okay? If I were guessing when I make the test, I will probably put 20 chapter 12 problems and maybe 5 chapter 13. Okay? Chapter 13 is not nearly as important as chapter 12. Gotta do chapter 12, because if we go to chapter 15, if you can't find a derivative, you're never going to be able to relate back to going and finding an interval. Okay? So our study guide is to study your chapter 12 test, same study guide as you had for the chapter 12 test. Let's add these problems for chapter 13.